I did a video tutorial playlist going over in detail about the skills in the rational numbers content assessment, and that took a very long time. Then I did a practice worksheet that broke down each of the skills in a little less detail, but still it took a very long time to get through it all. So this is more of a short workshop, the kind that you would have in school, to just review and help students which are really close to passing the PFA and have a general understanding of the skills, but just need a little bit of last push to actually get it done. Now, if you don't really know what you're doing, this may not be the right video for you, okay? But anyways, the first problem here involves adding or subtracting fractions. And so we have to find a common denominator, which in this case is going to be 8. And since it's 8, 3/8 is not going to change. And you can rewrite 1/4 as 2/8. So this is negative 2/8 would be the same thing. And you can get to the same place by doing common denominator work, but I'm just trying to save time. And that's how you would actually get if you actually did the common denominator step. Once you do that, you actually copy down the bottom. All right, so the denominator does not change. And then you add up the top, 3 plus minus 2. Two different numbers, so you have to find the difference because the signs are different. And then you have to keep the sign of the biggest, which is 3. So the answer is 1/8. If you do need review on how to find a common denominator to get to this step right here, watch the longer video when I go into detail on that. All right, next problem, subtraction. So we actually have to change the sign of the operation first and then change the sign of the next number. That's how you do it. Now I realize back to addition rules. I'm adding two numbers that have the same sign, so I just put them together and keep the sign. 14 is my answer. Here's another addition problem. I'm adding two negatives. They have the same sign. So once again, I put them together. Putting those together makes 15, but I keep the sign, so negative 15. Here's another addition problem. This time, though, I am adding two things that have different signs. And so when I'm having different signs, I have to find the difference between them. And since this has a decimal, I actually have to kind of line up the decimals and do this vertically. And I can't do that in my head. So, well, actually, probably could, but I need to show you guys how to do this. So I'm finding the difference between the numbers. So line it up. I have to borrow from the 4 here because 6 does not fit into 0. And now it becomes 10 and I can do it. But then I have to borrow from the 10 to turn this 0 into 10 so that the 2 can go into it. The difference between 2 and 10 is 8. The difference between 2, 6, and 9 is 3. And the difference between 8 and 3 is impossible. So I have to borrow from the 1. Forgot to do that. And so now you have 8 and 3, which is 5. So the answer is 5.38. Now, because 14 is bigger, I will keep the sign of the biggest. That's what you do. Find a difference, keep the sign of the biggest. So it's positive 5.38. Last but not least, one last subtraction problem. Do not mess with the subtraction sign of the leading number. Slash here, and then change the sign of the next number. Change the sign of the operation, change the sign of the number that follows. So it looks like once again, we're back to adding two negatives. And so we're going to make a bigger negative, keep the negative, and then put the numbers together and you get 6, negative 6. So that is reviewing the rules of adding and subtracting with a little bit of fraction and decimal work thrown in for a good measure. Remember, basically you add the numbers or put them together if they have the same sign. And if they have different signs, you find a difference, right? And if it's subtraction, you must first turn that into an addition problem by slashing the sign of subtraction and changing the sign that's next to it, because subtraction is like adding the opposite. For decimals, just make sure to line up the decimals before you actually find a difference or put them together. And for fractions, got to find a common denominator before you do it. Keep the denominator at the end, and at the top, you operate like you normally would as if the denominator was not there. That was objective 1. Objective 2 is all about multiplying and dividing. And you just do it the way you always did in your life, but you have to be aware about the signs. So if there's a negative sign involved, you have to also think about the sign. Remember, if there's an even number of negatives, then the answer is going to be positive. If there's an odd number of negatives, the answer is going to be negative. Two negatives cancel out when dividing or multiplying. There's a little bit of a fraction and decimal practice here too, so let's actually look at those to see how to do it. The first one, you're dividing by a fraction. Remember that when you divide by a fraction, you just copy down the first number, and because I'm going to do a fraction, I'm going to put the 1 that's underneath the 8th. Remember, 8 over 1 is still 8, so if there is not a number underneath, that's the one that's underneath, a 1. Then you change it to a multiplication sign. That's the dot part of copy dot flip. And then you flip the second fraction without changing its sign. So that's going to be 4 over 1. And now you do the normal top times top, bottom times bottom. That's how you multiply fractions. So 8 times 4 means 32. 1 times 1 is 1, so that's just 32. And then, because there's a negative sign involved, I have to think about the sign. Only one negative sign, nothing to cancel it out. An odd number of negatives means the answer is negative, negative 32. All right, this is going to be a positive answer, and so is number 3, because there are no negatives involved, and so it's just really about multiplying. To multiply a decimal, you just do this kind of thing, pretending the decimal is not there, and just multiply like you normally would. 5 times 2 is 10. 1 carries over. 5 times 25 with the 1 that carries over is 26. Then you count the number of decimals in the problem. There's 1 decimal up there, and so there's got to be 1 decimal in the answer too. And so the answer here is 26.0, which is just 26. The next one is going to be another fraction division. Remember, you copy dot flip. So copy the first fraction, change it to multiplication sign, flip the second one. And then you do top times top and bottom times bottom. And that would be 9 times 16, which would be a pretty big number. But the bottom is just 16 times 1, which is 16. And then 16 divided by 16 is just 1. So this is just 9. All right, so it's supposed to be easy for you guys to do it. But you could have do 9 times 16 and then just divide by 16 again, and you're going to reverse what you did. So we would just get back to 9. All right, so over here we have another one, negative 9 divided by negative 2/3. One more of these copy dot flips. You see a pattern. There's going to be several of those in the actual test. So you're going to flip the second fraction, but notice you don't change the sign. It was negative 2/3, so it's still going to be negative, negative 3/2. Remember, if there's not a number underneath the number, that's just a 1. Then you do top times top and bottom times bottom to do the fraction. 9 times 3 is 27, and 1 times 2 is 2. So you get 27/2, but negative times negative is positive. There's an even number of negatives that averages cancel out, and then you end up with a positive answer, 27/2. Or I think if the options, so the multiple choice options are decimals, I think this would be 13.5. Okay. Now, 4 times negative 2, that's just 8. But there's a negative sign, so I have to think about it. It's by itself. It doesn't cancel out. So the answer is negative 8. And so there you go. That is the objective number 2. Essentially, it's just about remembering that those rules of multiplication and division when it comes to signs. The rest is just the same as you used to do in 5th and 6th grade. Copy dot flip for fractions. And when you're dividing, when you're multiplying, is just top times top and bottom times bottom. Multiplying decimals is just regular multiplication, but at the end you have to count the decimals in the problem and make sure that the answers have just the same number of decimals. Remember, negative times negative cancels out, even number of negatives. Negative times positive becomes negative, and if there is no negative, positive times positive, the answer is positive. The last objective is about understanding that there are different ways to write the same expression. When you have subtraction, for example, that's the same as adding the opposite. So you're going to have to look for options where they literally did that, right? Change the sign to adding and change the sign of the number afterwards. So this would be the same thing as that, right? The first expression would be the same thing as that one. Now, the same thing here, you would have slash here and slash here. So 4 minus minus 3 is the same thing as 4 plus 3/5. And essentially, what they're testing there is that you know that multiplication is essentially adding, not multiplication, subtraction is essentially adding the opposite. With problems that say to find equivalent expressions to something that has to do with division, they're testing that you know that you cannot change the order, because if you change the order, it changes the operation. By the way, the same thing applies to subtraction. You can't change the order. The numbers will still show up in the same order when you do them. Now, this can't be 2 over 50. It still has to be 50 divided by 2 for you to get that 25, which is going to be the answer for this one, right? Now, you can change where you put the negative. You can put the negative next to the negative to the 2. Why? It doesn't matter where you put the negative because 50 divided by 2 is going to be 25 no matter what. And as long as you have one negative, the answer is still going to be negative in the end. Negative 25 is your actual answer over here. So what are they testing there? They're testing that you realize that you cannot change the order when you do division, and that as long as you have the same number of total negatives, the answer is still going to be equivalent. The same thing is true when you're multiplying. You can write this negative in a lot of different places. You can do 1/5 times 1/3, and then put the negative in the -9. As long as the total number of negatives in the problem stays the same, that's the same answer. Or you can put the negative in the -1/5, and that's okay too. You can even change the order, but only in multiplication. If there's a bunch of multiplications only, it doesn't matter if you write in the same order. It will still be the same answer as long as you put the same total number of negatives. And it could be there, or it could be the -5, but then there can only be one negative. If there was two negatives, that would not be equivalent. So there they're testing that you know that the order doesn't matter in multiplication, and that as long as the total number of negative signs is the same when you're multiplying, the answer is still going to be the same. But honestly, there is a different way to approach these equivalency questions. So every time you see a question that says, which of these is equivalent to, this is my advice. This is what I would do if I were you. I would actually multiply each of these expressions out to see what I get, all right? So for example, following your order of operations, you do one step at a time. 3 times 8 is 24, and then times that -9, you actually get -216, right? And you can do this on the side if you have to, right? So 24, because you're not going to have a calculator. Now, we're really supposed to have a calculator. So 9 times 4 is going to be 36. 3 carries over. And then 2 times 9 is going to be 18. With the 3 that carries over, that becomes 21. So 216. But because there's one negative, the answer is negative. So 216 negative is the answer. All right. Now, when I approach the other expressions, what I'm going to do here is try to find out if each of these expressions, it has the same kind of answer. All right, so one by one, we're going to follow the order of operations and check to see if it's the same. -9 times 8 should give you -72, because negative times positive is negative. And then you still have to multiply that times 3, and guess what? That is also -216. So instead of trying to figure it out mentally, I can actually just do the actual math and figure it out. I could have realized that this is multiplication, so that this statement is the same as this statement in a different order. And like I just described, the order doesn't matter in multiplication, so you would have gotten the same answer. But honestly, for any one of these equivalency questions, I would just literally check if the option gives you the same answer. All right, let's check the same thing over here. Following orders of operation, you get 3 times 8 plus -9. They're different signs, so I have to find a difference, which is 1, and I keep the sign the biggest, which is -9, so -1. And so 3 times -1 is -3. That is not the same answer as the top. So I know that B is wrong. I also know that I could have realized that because if distributing the 3 to 8 plus 9 is not the same thing as multiplying those 3 numbers together. So that would have been pretty obvious. Now, the next one, once again, you can notice right off the bat, that is the same thing as the first expression written in different order. And since you recognize that in multiplication, the order does not matter, you would have been able to get that right. Or you can do the math once again. 9 times 8 is -9 is -72. All right. And then times 3, again, is -216. So you know that this one also works as a right answer. This one it's pretty obvious that it's not going to be right, because if you add instead of multiply, there's no way you're going to get the same answer. And in fact, this becomes 11 plus -9, which is the same thing as 2, so far from being the right answer. Okay? The next one, again, is the same statement in a different order, so you should get the same answer. 9 times 3, or -9, you're going to get -27. And if you multiply that times 8, guess what? You do get -216. And I skipped doing the actual math for those, but you would have to do that on the side without a calculator because you wouldn't have that. But my point is that you can, for these kinds of problems, you have two choices. You can remember what they're trying to make you remember, which is the skills I just described before, or you can actually evaluate each of the problems to fall in the order of operations and find the ones that actually match what you get when you evaluate the prompt. Okay? Now remember, the skills for objective 3 that I was trying to review is subtraction is just adding the opposite, so you can rewrite it as plus the opposite number. Division cannot change the sequence, but you can change the placement of the negative signs. So long as you have the same total number of negative signs, it's going to be equivalent. Multiplication, you can change the order and change who has the negative signs. As long as the total number of negative signs stays the same, it's going to be equivalent. So here's in a nutshell a review of everything we talked about in this video. For objective 1, remember, it's just adding and subtracting. So add numbers. Remember that if they have different signs, you'll find a difference between the numbers and keep the sign of the biggest value number. If they have the same sign, you also keep the sign of the biggest, which is basically going to be the same sign as the other number because they both have the same sign, obviously. But you put the numbers together instead and keep that sign. In subtraction, you just change it to adding by changing the subtraction sign between the numbers and then changing the sign of the number that follows that. Do remember not to change the sign of the leading number. You do this because subtraction is basically adding the opposite. Then you follow the rules of addition that I just talked about. If you're doing this with fraction, you must first make sure that to adjust the fractions so that they have the same denominator. They have to have a common denominator. And that's a 6th grade skill that you should review if you don't remember how to do it. I do talk about that in another video, remember. But the final answer will have the same denominator as that common denominator, and you will operate the numerators as if the denominator was not there, following the rules that I mentioned above. Finally, if you're doing this with decimals, you must first determine what you need to do, following the rules above. And if you find a difference, which is going to be the case if you're trying to add numbers that have different signs, you're going to set them up vertically and subtract them, making sure to put the bigger number on top. If you're trying to put them together, which you're doing because the numbers have the same sign, then you add them vertically and making sure that you line up the numbers and padding any numbers that have less decimal points than another, and then line up the decimals correctly. And then don't forget at the end to think about the sign of the answer. Remember, the sign of the biggest always wins. For objective number 2, it's basically using multiplication tables with dealing with numbers that as you normally would. But remember that if there's a negative sign involved, you have to remember to calculate the sign at the end, thinking that if there's an odd number of negatives, the answer is going to be negative because they do not cancel out. But if there's an even number of negatives, that means a positive answer because every pairs of negatives can cancel each other out. Now, if there's a fraction, you follow the same logic above at the end to figure out the sign of the answer. But to calculate the numbers, 6th grade skill, multiply top times top and bottom times bottom. And to divide, copy that flip. Copy the first number, change the sign to multiplication, invert the fraction without changing the sign, the second one, and then multiply as usual. Now, if there's a decimal involved, follow the same logic above again to figure out the sign of the answer at the end, but do a normal multiplication vertically, making sure that probably putting the one that has the least digits on the bottom to make things a little bit easier. But remember that the total number of decimals in your answer has to be the same number as the total number of decimals in each of the numbers involved. So like if you're multiplying 3.2 and 3.22, since 3.2 has 1 decimal and 3.22 has 2, the answer would have to have 3. On objective 3, basically you're trying to see if things are equivalent. In subtraction, they will be equivalent if they basically change the sign of the operation to adding and the sign of the number that follows, without necessarily changing the numbers or the order they're put into. For division, the expression has to be in the same order, but you can change who has the negative signs so long as the total number of negative signs is the same. In multiplication, you can even change the order. That doesn't matter. But you must make sure that the total number of negatives stay the same, even if you can change who gets it. In addition, the order does not matter either, so long as the signs of the numbers and the numbers themselves stay the same. Lastly, an alternative way to figuring out those expressions is to use order of operations to evaluate the prompt to get a final answer, and repeat the process for each of the options offered to make sure that the answer comes out to be the same. And that's essentially it for the skills of rational numbers. Those are the skills that I showed you on the video and reviewed multiple times. I hope that's clear. If not, I'm here for you to help you out. Don't do anything that would not make your mama proud. Good luck.